we created an infection-resistant synthetic aortic graft. I'm Nicole.
I'm Rachel.
I'm Michelle.
I'm Marianne.
Each year, 200,000 people in the United States are diagnosed with an abdominal aortic aneurysm. This occurs when the aorta becomes weakened and enlarged and requires a vascular graft, as can be seen in the picture below. Between 1 to 6% of vascular graft replacements result in infection. While this percentage may be low, the complications are devastating. If infection isn't detected early enough, amputation can occur or death. Currently, the mortality rate is 25 to 75%. Medical and surgical treatment of infection costs $40,000 per case.
To treat aneurysms, one option is biological grafts. These include autografts, however, there's no adequate source within the body for autografts. Then next we have allografts and xenografts, which have been found to have adverse immune responses. So in order to avoid the response, there's been research for decellularized grafts. However, these are more expensive and could result in another aneurysm because it's made from tissue. Next category, we have tissue-engineered vascular grafts. However, these lack mechanical strength and difficult to get approval for a cell source. And lastly, we have synthetic grafts. These most commonly are Dacron or Gore-Tex, and these can have low endothelialization or result in infection through the formation of a biofilm. Biofilms are 10 to 1,000 times more resistant to antibiotics than free-swimming bacteria, so there's a need to create a vascular graft that provides this prolonged infection resistance against biofilms while ensuring mechanical strength, hemocompatibility, and endothelialization.
To meet the needs that Rachel and Michelle both talked about, we've designed an infection-resistant graft. It has a Dacron base and an internal and external layer that fights infection. It can be stitched into the body, and now we'll tell you more about the layers.
So for the internal layer, we want to have a drug-eluting polymer. We want to use polycaprolactone because it degrades between 6 months and 2 years, and it doesn't produce the acidic byproducts that other polymers do. We want to create an electrospun scaffold with this PCL, and electrospin in with it triclosan, which is an antimicrobial agent, and heparin, which is an anticoagulant. So in order to further induce endothelialization, we want to attach RGD peptides to the PCL surface, and this can be done using cross-linking so that the N-terminus of the RGD peptide is still able to attach to the endothelial cell.
The inside surface coating that Marianne just talked about will be applied to a Dacron vascular graft to provide for the structure. Dacron is used in 80% of large vessel synthetic grafts, and it has a high tensile strength for blood pressure. The outside surface coating will be electrospun PCL with triclosan for the antimicrobial properties, and the graft will be sterilized through gamma irradiation.
As you can see, the benefits fully outweigh the costs. Benefits include prolonged protection against biofilms, which also helps decrease the chance that the patient might need a second surgery. It also increases blood compatibility and endothelialization, and this technology in the future might be able to be applied to other types of grafts used within the body. The minimum costs include fabrication and FDA requirements, and all of these benefits provide a lot of value for our stakeholders, which include patients, surgeons, and insurance companies.
So lastly, we have our competition, which include decellularized grafts made by CryoLife and Artegraft. These, however, are not widely adopted and have been found to have no clear advantage over synthetic grafts. So then moving on to synthetic grafts, we already talked about Dacron, but there's others made by Marquet, like Fusion Bioline, which is Gore-Tex and PET layered, and however this does not have infection resistance. Their other product, Interguard Synergy Graft, does with a silver and triclosan coating. However, this coating only lasts for 7 days within the body, so there's no prolonged protection. And lastly, we have stent grafts, these made by Medtronic and Gore Technologies. These are more minimally invasive, however, they have a 3 times higher reintervention rate. So overall, we think that our product would outweigh the competition.